Yeah, welcome. I am T. Anoop Kumar, Professor, Department of Mechanical Engineering, and I will be handling in this semester the subject Gas Turbine Engineering of MTech Thermal Engineering. The course code for this is 18ME52G2. This course broadly deals with the gas turbine power plants, and we will discuss about the basic functioning of this gas turbine power plant, and then subsequently we will come to know about the various parts or thermodynamic units of gas turbine power plant, like a compressor, a combustion chamber, the gas turbine, and of course the gas turbine power plants are present for terrestrial applications as well as for aviation purposes. In addition to the terrestrial applications, we have aviation gas turbine power plants where we have two more additional components, namely the ram and the nozzle, in addition to the compressor, combustion chamber and the gas turbine. So, that also we will be going to discuss in this subject. And pedagogically, I would take you first through the thermodynamic analysis of this gas turbine power plant in combination with all the units at a very broad level. You can say a kind of lump system kind of thing, and subsequently we would be discussing about the performance of each individual thermodynamic component in this gas turbine power plant, that is the compressor, the combustion chamber, the gas turbine, nozzle, a ram, like that. So, initially following the fundamental thermodynamics laws, we will find out the irreversible losses that occur in the each individual component, and then we sum them up over the entire gas turbine power plant. This analysis is based on both the theoretical analysis as well as the actual analysis. Now, coming to the other issues which we address after the basic thermodynamic analysis are the integration issues, like how do we integrate the compressor, the turbine, the combustion chamber, and of course the ram and a nozzle in case of an aviation gas turbine power plant. Though we address at a basic level the integration issues, but we concentrate more on the integration issues of compressor and turbine at a more deeper level. After looking at this, we then proceed to the practical issues of cooling problems that arise in a gas turbine power plant. As we very well know that the highest temperature in an IC engine power plant is around 2000 degrees centigrade, whereas in a gas turbine power plant, though the highest temperature is at around 800 degrees centigrade, but still there are phenomenal cooling issues that arise because of the continuous soaking of the gas turbine blades in very hot gases continuously. So, the cooling of blades is a major area of research and analysis in gas turbine power plants. So, therefore, we would be spending some time on looking at the heat transfer issues and how to cool them and the various techniques involved in cooling the gas turbine power plants. When we talk about cooling, we need to look at them in terms of material selection for the gas turbine blades, as well as the design of the geometry of the gas turbine blades and the associated other minute geometric details. So, we will be concentrating on all these three, and after tackling these, we move on to the material selection with regard to the various components of gas turbine power plants, be it either compressor, the combustion chamber or the gas turbine. And specifically, as I mentioned earlier, the blades materials occupy the predominant point of discussion in this course, and other sealing materials, the seals and all that, and not just the material selection, but how to fabricate them would be the the logical extension of our discussion subsequent to the material selection. So, the geometry design in terms of aerodynamics, in terms of material fatigue, in terms of the maintenance, and in terms of long life would be discussed. The sealing materials would be discussed, the various protective coatings that we apply over the gas turbine blades to maintain them at appropriate low temperature and not to cause failure would also be discussed. the manufacturing techniques, 5 or 6 techniques we would be going to discuss about the various gas turbine components and also the combustion chamber components. Subsequent to that, after the analysis is carried out for a terrestrial gas turbine power plant, we move on to the aviation gas turbine power plants, where we would be looking at the differences between these two GTPP, that is aviation GTPP and the regular terrestrial GTPP, and we would see the various gas turbine power plants in aviation applications. Like we would be first looking at the ramjet engines which are used for defense missile applications, and then we will look at the gas turbine power plants where we have the turbo propeller engines, turbo jet engines, and we will compare them. We would be solving some design related problems of finding their efficiencies, their performance, how the performance change with respect to some important operating parameters of the gas turbine power plant. And after this, we would be looking at the most modern thing, modern in the sense the last 2 or 3 decades, the integration of the gas turbine power plants with the regular Rankine cycle power plants, that is the steam turbine power plants, has been in vogue for quite some time, and the technology has also matured. So we would be discussing about the cogeneration aspects and the combined cycle power plants in this subject. In cogeneration, like say for example in your sugarcane power plant or sugar plants, where the gas turbine exit gases would be used to heat the steam, which would be used to heat the sugar crystals and all that, and so where we would be using the power for heating as well as the power that would be covered. And then in combined cycle power plant, we would be talking about the integration of the steam turbine power plant with the gas turbine power plant, thereby increasing the overall economics of the power plant operation, as well as improving the power as well as the efficiency. So these are the things that we are going to discuss at the end of this subject. And coming to the broad, see the whatever I have told, it would be coming under 3 broad course outcomes of this subject. One is the analysis of the gas turbine cycles at a broad level and as well as a component level, and then analyzing the performance characteristics of compressor and turbine in detail, and then we will understand how to select the materials used for the various components of these gas turbine power plants, like blades, the sealants, and the various fabrication techniques. This would be the course outcome number 3, and at the end of the thing we would be talking about the gas turbine, cogeneration and combined cycle power plant, which would form the course outcome number 4. After this, I wish to tell about the evaluation pattern for this subject. As you know, we have the formative evaluation as well as summative evaluation. The formative evaluation is for 60 marks and the summative evaluation is for 40 marks. And in formative evaluation, we have 4 components, that is the SEM in examinations. We will have 2 SEM in examinations, and we will have the assignments, home assignments, and then we have a quiz test covering all the COs, and then we have the evaluation based on some marks for your attendance. So this is how I sum up this subject, gas turbine engineering, and I welcome you to this course, and I look forward to take up this course for you in this semester.